9.5 is inelastic collisions. If we drop the rubber ball on the floor, it bounces. That's elastic collision. If we drop the clay ball on the floor, it sticks to the floor without bouncing. That's inelastic collisions. The golf club hitting the golf ball, what's that?
Inelastic.
Semi-elastic.
The golf club hitting the golf ball. What happens to the golf ball?
It goes.
It goes. Okay. So what is that based on the examples?
Elastic.
That's elastic.
That's inelastic. What?
Have you ever seen a golf ball?
So
in
what if
slow
you
motion
put
when it's getting hit?
glue on a golf ball and then you hit it?
It'll still go. because
Basically-
it's not strong enough.
Why is this one, the rubber ball, elastic?
It's made
What
out of
happened?
rubber. It bounced.
It bounced.
Move.
Why is this one inelastic?
Keep move.
It's stuck. Okay. So inelastic means it bounces. Elastic means it bounces. Inelastic means it sticks.
But when
Okay.
you hit it with the golf club, it's not bouncing.
Okay. So what happens when the golf ball or the golf club hits the golf ball? Do they get stuck together?
That'd be funny.
No. It's like a bounce, right? So is the golf club hitting the golf ball elastic or inelastic? It's elastic.
For some.
The bullet becoming embedded in a block of wood.
Inelastic.
That is inelastic. All right, so a collision in which two objects stick together and move, maybe they move, maybe they don't move, and move with a common, this is final velocity, is called a perfectly inelastic collision. They stick together and move with a common final velocity. And that common final velocity could be 0, but they stick together, okay? Now, maybe they don't perfectly stick together and move with a common final velocity, then it would not be a perfectly inelastic collision. Maybe they don't bounce perfectly, then it would not be a perfectly elastic collision. There's some in between going on, then we have some loss there, okay? That's fine. But in this case, where they stick and move together with a common final velocity, that is called the perfect inelastic collision, okay?
So can you have like a semi-elastic collision?
That's what I'm talking about, where it's not perfect. Then there is something going on in between, okay? So two objects approach before. We have mass 1 and velocity 1 moving to the right. We have mass 2 and velocity 2 moving to the left. Now they hit, they collide, and they stick and move together. So the combined mass m1 plus m2, and they also have a common final velocity. Perfectly inelastic collision. Okay? And so that's what we're studying in this section. We have the inelastic collisions going on. Okay? So, in assembling a train from several railroad cars, two of the cars with these masses are rolled towards each other. When they meet, they couple and stick together. We're talking about an inelastic collision then. The lighter car has an initial speed of 1.5 meters per second, and the collision causes it to reverse direction at 0.25 meters per second. What was the initial speed of the heavier car? So the first thing we should probably do is
Before and after.
before and after pictures. Yep. So we have before, and over here I'll put after. So in the before, we had one car moving, I'll say to the right, and we must have had another car moving, since they're toward each other, to the left, right? Okay, so which one's which?
Make the one moving towards the right.
Heavy.
The heavier one? Okay. So we can call it mass 1, we can call it mass A.
Call it mass 1.
Mass 1? Okay. So mass of the first car is the heavier one. This is 4.0 times 10 to the 4th kilograms. And what do we know about this one? Anything?
It's moving that way.
It's moving that way. Do we know its speed?
No.
That's
Okay,
what we're finding.
so that's what we're finding.
We don't know its velocity initial, but we do know
Initial
its
velocity.
final.
We don't know. Final velocity.
It's going to be 0.25 meters per second. Right.
And it said that the other car reversed direction. So the final velocity of this one is actually going to be still to the right. Yeah? Okay. So we don't know. All right. So then still in the
Yeah,
before.
we do. Yeah, we know the final velocity of that. It's 2.25.
0.25.
Oh, yeah. That's right. Okay. 0.25 positive meters per second. Good. Okay, now the other car,
We know its mass.
mass 2. 2.0 times 10 to the fourth meters per second. And what do we know about this one?
That its final velocity is negative
It has an initial speed of 1.5 meters per second,
in the negative direction.
but it's in the negative direction. So V sub I. Okay, so V1 initial over here, V2 initial here equals negative 1.5 meters per second.
And then its final is a positive 0.25.
So V final is the same for both.
Yeah.
So
Okay.
you don't need to write it.
I don't need to write it twice. All right, so what are we looking for here? The initial speed of the heavier car is what we're looking for. Okay.
We use that theorem, right?
What's the theorem?
Mass times velocity initial plus mass times velocity initial is equal to mass times velocity final.
Good. But let's finish the after drawing. What is the after drawing?
They're stuck together.
They're stuck together.
Moving still towards the right.
Okay, so the combined mass, M1 plus M2, is,
6.0 times 10 to the fourth.
okay, 6.0 times 10 to the fourth kilograms. And V final is
0.25.
positive 0.25 meters per second. All right. So you said the theorem tells us that the initial momentum equals the final momentum, basically. So we have, what can I write?
Mass 1 times V1I,
Mass 1.
or V1F minus V1I. Right? Which is just going to be VF.
We're going to say mass 1, V1, initial.
Oh, that's right.
Plus
Yeah, plus mass 2
mass 2,
times VI initial. V2.
V2, initial, equals,
We can just do the mass of the system, can't we? So M1 plus M2.
so M1 plus M2 times
VF.
V final. Okay, what are we looking for?
We are looking for VF, so we can.
We're looking
We're
for
looking for the initial of M1.
V1.
V1.
V1 initial. So we're going to solve for V1 initial. How do we do that?
Move, subtract.
This term goes to the other side. So I have M1 plus M2 VF, now minus M2 V2 initial. And then what am I going to do if I'm solving for V1I?
Divide by mass 1.
Divide by mass 1. Now, that's mass 1. Always, I like doing it this way because maybe something would divide out that I wouldn't have seen otherwise, and I can save myself a little bit of work. Is anything dividing out here?
Yeah, mass 1 is.
Mass 1 does not divide out because it does not appear in this term, only in this term and the denominator. So nothing divides out here, unfortunately, but I can plug everything in now. I have V1 initial equals all this stuff. Now we know mass 1 plus mass 2 because we figured it out already. 6.0, 10 to the fourth kilograms. We know V final, 0.25 meters per second. Mass 2, V2I. I'm running out of room. This is great. We have mass 2 is
2.0.
kilograms.
Which is what? Metric tons? 20 metric tons?
Oh, I don't know. We have V2I. Meters per second.
And then finally divide that all by 4.0 times 10 to the fourth. I got, for velocity, I got 1.125.
1.125. Significant figures would be probably 2. So we're going to call it 1.1 meters per second. There you go.
That makes sense.
All right, the two objects here collide and stick together. After the collision, what do the combined objects do? What do you think?
I know. Huh? I did the math already.
Oh, you did the math? Yeah, really, you're going to have to do the math on this. What is the momentum of one?
1.
It's 1?
1.
Okay. What is the momentum of 2?
1.2.
1.2 going the other way, right?
Yeah.
So we have 1 to the right, but 1.2 to the left. Who wins?
1.2.
1.2. So which way are we going?
To the left.
We're moving to the left in the end.
It doesn't even matter.
And that's it, the whole section. One example, something to think about, but real straightforward stuff.